thank you for joining us. My name is Dwayne Henderson. I'm with the Cree Lighting Training and Education team, and I'm the host of the e-learning series we're putting on. For those watching live, happy Wednesday. We're in the middle of the week here. Just a little bit about the sessions. They are 15 minutes in duration once we start with our presenter. The presenters will hang around for Q&A after the session, so they will be available for that. The attendees are all muted, but we do encourage you guys to use the chat box and the Q&A box to ask questions. Feel free to type those in during the presentation, and again, we'll review those at the end of the session. Wednesdays are typically an industry-related content session. More specifically, the first three Wednesdays have been Wellness Wednesdays, and I'd like to invite back Shirley Coyle for her second of her three-part series on lighting for well-being. Welcome back, Shirley.
Thank you, Dwayne. Glad to be here. Hello, everyone.
Great. Well, this session is entitled The Well Building Standard and Lighting, and we had a session one previously, but before we get started, for those that missed the first session, can you quickly tell us a little bit about your role within the business?
Sure. I'm fortunate to lead a team of specification sales managers who are deployed regionally within North America. So this is a team that's available to support the lighting design community, lighting consultants doing lighting design or lighting designers, and as well as our agent partners. And so our team is available. My contact information is at the end. We can provide assistance, collaboration, including with our working with our team of applications people within Cree Lighting. So there are a lot of expertise in the team, and I hope that hope you guys will consider tapping us.
Great. Thanks, Shirley. And why don't we get started? Remind us maybe where we were last week, where we're going this week, and then maybe where we'll be heading next week.
Sure thing. So with this series, as Dwayne mentioned, we're doing short sessions on design, application, and technology for members of the lighting community. So we've divided lighting for well-being into three parts because it is such a big topic. The first session on the effects of lighting on human health was done last week, as Dwayne mentioned, and can be found on Cree Lighting's YouTube channel. In today's second installment, we'll dive into the well building standard. We'll see how lighting plays a part in the standard, and review the requirements and go through some metrics and tools for validating whether a design meets the standard. And then the final session for lighting for well-being will be next week on Wednesday, April 15th, when we look into several case studies related to lighting for human health, lighting and human health, to get a feel for the results in the field to date and to understand which application areas seem to be moving ahead. So let's get started on session 2. So here's the cover of the WELL version 2. The WELL building standard is a voluntary building standard, and it's focused on human health and wellness. WELL is meant to address all aspects of the built environment that have influenced human health and well-being. So the original standard was based on about 4 years of work from leading scientific, medical, and building construction and engineering experts, and a revised version of it was introduced in 2018, and that's the most recent version we're going to be talking about. So why would someone come to you or to one of your clients and say, we want our space designed to this? Well, it's typically large employers, building owners who have large inventories of property, and large developers asking for their projects to be designed to meet well. And their goal is usually to create an environment where people can be more productive, more satisfied, healthier. It helps them attract and retain employees. It also makes commercial real estate more desirable, more valuable. So that's what's behind the standard. If we look into the details of it, there are 10 concept areas. This is adjusted slightly in the new version 2. And within those 10 concept areas, there are 23 mandatory preconditions that have to be met to get your building certified or the space certified. And then there are an additional 97 optimizations. And I've got the little arrow going to light here. That's what we're going to focus on today, lighting specifically within the standard, but you'll see there are lots of other areas that have to be satisfied as well: air, water, nourishment, sound, materials, the community. So for the lighting portion of it, the thinking behind this for the WELL standard is that we know now that lighting, humans spend a lot of time under lighted environments, and it has a big impact on their visual and circadian mental health. And currently, the feeling is that most spaces are designed strictly to meet the visual needs of individuals, but don't really take into account circadian mental health. So WELL Building as a group, or IWBI, who manage this, they believe this is an opportunity for us to provide lighting conditions required for humans for optimal health and well-being. So let's go a little deeper into lighting specifically. So in the lighting concept, there are two features that must be met, and those are feature LO1 and LO2. So the first is light exposure and education, and in a minute I'll kind of translate what we're talking about in each of these areas. The second is the visual lighting design, which is the typical lighting designs that you or your clients might be doing right now if you're working with lighting designers. And then there are a number of optimizations. The first is circadian lighting design, so we're going to go a little deeper on that since this topic is on lighting and well-being, and that is the area where we're looking at what's new in terms of trying to design to have impact on the circadian system and human health. The others are some typical things that are already dealt with in designing spaces, so glare control, daylight access, visual balance, and electric quality and controls. So this next slide is my attempt to relate each of these categories in the WELL Building Standard. In red is sort of what I've done as a sort of shortcut for how it connects to lighting practice or specification. So thinking about the very first one that's mandatory, this is really the first tenet of most people doing lighting design and architects for sure. We want to take advantage of the natural light that's available. So you always start with daylighting. So giving as much access as possible to light exposure. And then the other piece, light education. In this document, that means that whatever you do in terms of the design, you also want to make sure that there is some planned promotion of lighting education to the users in the space, and that would be providing educational resources on circadian rhythm, sleep hygiene, age-related requirements for additional light, and the importance of daylight exposure for circadian and mental health. So those things need to be thought about in the design and information given. And then for the feature 2, which is the visual lighting design, this is the concepts that are already done for spaces, coming up with the concepts, doing the lighting design, doing the layouts and calculations for it. So just doing those two will satisfy the lighting concept, but then there's an opportunity for getting additional points by hitting on some of the optimizations. So if we run through those quickly, the first optimization here that is feature L03, circadian, we're going to talk more about that, but for this, it really translates into making sure you have the SPD, or the spectral power distributions, the spectral data file for the luminaires you choose to use, and that you do, it's more complex than this, but you will do the figuring out of where people are sitting, what their viewing angles are, and do the calculations at the eye for how much light is getting in. So that's feature 3. The next optimization is glare control. This is something that's already being done every day by people who are designing and specifying lighting. And for that, we need the luminance data, and that can be, in Europe, it's more common to use the UGR, the Unified Glare Rating. In North America, we're typically using luminance data that is part of the data that manufacturers are collecting when they're having their photometric testing done, so you should be able to get luminance data. The next one is enhanced daylight, feature 5. This is a very broad, a very big area that requires special expertise. So there are people who do a lot of daylight work. It really involves having a daylight plan in terms of how you're going to give people access. SDA is the spatial daylight autonomy. So this is where you think about how much how much of the space receives natural light. It describes a percentage of the floor area that gets at least 30-foot candles or 300 lux for at least 50% of the occupied day. So there are special things you do for the daylight in certain spaces to get the points. Visual balance, I've got a very sort of general, ill-defined comment here that says manage brightness, and this is something that consultants and designers do every day in figuring out what to do to make the space comfortable, so you're not putting somebody that within their viewing space they're not uncomfortable by the either direct light or reflected light or daylight coming into the space. Feature 7, electric light quality. This is where you would get points, get a point for being able to demonstrate you've chosen luminaires that have good color rendering quality, good color quality. So either color rendering index or the newer IESTM 30 data where you've set parameters there. And then the other aspect for electric light quality is flicker. So using some of the, there's a few different possible metrics for that. And then the final one is the area of controls, which I think everybody on every job is looking at this. There are very few spaces now that you would design without having some kind of controls, but you get a point for giving individuals control over their environment. Okay, so mentioned just here the WELL certification process, that it is a fairly arduous process, similar in some ways to LEED in that there's a lot of upfront work, registration, verification of the performance, then certifying. There's also a recertification process which goes on periodically. So you will run into some clients who actually don't want to go through the whole process of registering, but they want your client to design to WELL, but not actually go for the certification. So I think the main thing to think about in terms of the design community is that this takes a lot more hours. You've got a lot of extra work in here, needs to be reflected in the fees, and there is likely going to be additional cost in terms of the features that are designed into the building. So we talked about last week this issue, and this is a central one for using WELL building, in that typically when we design our practices, our recommended practices talk about illuminance, the light level on the task, either horizontal or vertical task. For looking at circadian lighting, that feature specifically, we need to look at the light at the eye, what's coming into the retina. And it's a little more complicated in that we need to look at intensity, we need to look at the spectrum, the spectral power distribution. The distribution of the fixture makes a difference if you think about the angle getting it into the eye, and then the duration, how long are they getting it? Most of the standards recommendations out there are for 3 or 4 hours in the morning. There should be an elevated amount of light, that is, if you're trying to affect the circadian system. So what kind of metrics or models are used to talk about the light at the eye? We're going to talk about 2 of them, and these could be sessions on their own, so just sort of touch on these, and we can always go deeper in a separate session. EML, equivalent melanopic lux, is the primary one that's referenced in the WELL standard. Circadian stimulus is also, both of these are models that are based on taking into account the spectral power distribution rather than simply the amount of light and regular lumens. So both models look at the light entering at a vertical plane. So let's look first at EML. Here you're going to see this is the human eye, the visual response, our V lambda curve. The way we count the number of lumens in a source is for this kind of visual response. Well, we know that for stimulating the circadian system, it's the melanopic curve, which is shifted slightly down, and that's, you can see it's more sensitive to the shorter wavelengths, the bluer, blue-green sort of wavelengths as we characterize them. Showing you 2 different spectral power distributions here to reinforce the fact that just because something has the same CCT, both of these are 4000 K, one is a fluorescent, quite spiky, the other one is 4000 K, but it's an LED source. You can have very different amounts of melanopic stimulus in a 4000 K source depending on what you're using. So it's really important how the spectral distribution of the source you're actually using. And what is done is that we basically come up with a ratio or kind of a derating factor or a prorating factor that says, okay, for this particular source, it's got a lot of melanopic content. So we're going to take our light level, our photopic output, and we're going to multiply it by this and either knock down, it doesn't get as much credit because it doesn't have much melanopic input, or it has a lot, so we're going to bring it up higher. So if we look at the two sources, that what the ratio is, this factor, the M over P factor, melanopic over photopic, in the column in the chart here for ratio, this is the fluorescent is a ratio of 0.58, so it's not getting quite as much credit. We'll take the photopic amount of light and multiply it by the 0.58. The LED, because it has more melanopic stimulus in it, it's going to get a higher rating. So the formula to get EML is basically taking the lux, or the light level at the eye, and multiplying it by this ratio. So that's how we get EML. Now, you don't actually have to. The good news is you don't have to calculate this yourself. There are software tools out there like this Alpha, which is a bolt-on for Rhino, a software that's used in design right now. There's also a worksheet that can be downloaded from the well building. It's in the appendix L01, where you can put in a manufacturer's spectral data file manually, and it will do the calculation and tell you what the EML is. The other one is the circadian stimulus that LRC does, and you can find lots of information online from them, but it also takes into account the light entering at the eye. And their recommendations, so the circadian stimulus, first of all, it takes into account spectrum, but the 0.7 that you see here, CS of 0.7, that represents the percentage of melatonin suppression. So it's suppressing melatonin. If you have a level of 0.7, it's suppressing 70% of your melatonin at that point. That's the highest that's ever been observed. The lowest, once you're down at less than 0.1 or 10% circadian stimulus, you're actually not able to see an effect on the melatonin. So they're suggesting early in the day. This chart on the left is from 7 a.m. to do higher levels, and then ramp it down during the afternoon, and then at night, in the evening, be into a warmer color, or just by the amount of light. So there are two ways you can affect, either by changing the spectral content up or down, or by changing the intensity, the actual amount of light coming in. So they also have a free download calculator on their website that you can look at. And really, we want to think about who's most at risk for out of sync circadian rhythm. A big target is office workers. Most of us spend a lot of time, at least prior to this situation, in spaces where we're drastically underlighted and not seeing what the body needs to know it's daytime. Same thing with nursing home residents, or often have long days under very dim lights, and the body, our circadian system, doesn't interpret it as daytime. So last comment is there's been a lot of change. This is a fluid thing. The well building people believe that, yes, they know there's a concern about doing harm out there, but their feeling is we're already doing harm by not having enough light in these spaces. So there have been a lot of changes over time, and we need to follow those. You can go through these. This was a presentation done by PNNL at the recent IES conference. And it really is to get us to think about that energy needs may actually go up for the first time in many years in these spaces, at least for the few hours a day where we're bumping up the light level. So you might design for the visibility task at 50% dimmed level, but then during the morning hours, you're going to need to have extra capacity, like have a fixture that has extra headroom that you can put it up for those few hours in the morning. So we need to think about the energy impact as well. So that's it for well version 2. That gives us a little walkthrough on the idea that you're integrating daylight and electric, the things you need to think about, the kind of data you need from your luminaire manufacturers. And that was fast, Dwayne, but I'm running a little late here for the timing. And so I hope you'll join us next week on Wednesday for the final installment of this, where we go through some actual case studies And I'll stay on the line now if there are any questions. Over to you, Dwayne.
Great. Thanks, Shirley. Again, if there are any questions, guys, please feel free to send them via the chat box or the Q&A box. Shirley, you touched on it a little bit last week, thinking a little bit about the dynamic systems, because it not only it looks like there's been some shifting in terms of what the recommendation is, but then also more light and dimming things down. So can you talk about the flexibility of systems that people should be thinking about today?
Yeah, and I think this is pretty much reflected in the state of best practice right now, is that most people would not put in a system without making sure that the luminaires are dimmable and that they have a range in terms of intensity, and then possibly also considering color tuning. There are lots of options out there for adjusting the spectral content. You may not do that in every space, but for particular areas, that's the way to do it. But you're certainly future-proofing if you design in systems that have some headroom to go to higher intensity levels, higher lumen levels, and that can offer some controls. There are a bunch of areas where even as we get more data, we'll be able to fine-tune it. You're not going to do this kind of design for every single space, and the well building doesn't have to be for the entire facility. It can be for the shell of the building. It can be for a particular space, an interior tenant fit up. So there are places where this takes a lot of effort and work, so it needs to be a special kind of place. And it's a lot of work because, especially for multifunction spaces, you could have a wide range of seating positions. You could have people at standing desks and in the same day then sitting, so you have to think about that. So there'd be a lot of calculation planes, a lot of extra work for the lighting consultant and lighting designer.
Yeah, Shirley, you mentioned that reference LEED in your presentation, and I think similar to that, where you're maybe not going for the certification, but you're designing that standard. Well, could be very similar, where especially from the lighting side of it, practitioners could look to incorporate some of the well concepts around lighting into what they offer to customers and clients to enhance value to the space without necessarily going all in for well, correct?
Yes, exactly. They can give them some of the benefits and leave them the tools if they want to use it. And we'll see that in some of the case studies next week in terms of how it's being used right now and where people feel part of it is giving people a sense of autonomy over what they're doing in their space while still maintaining kind of a cohesive design for the architect and lighting designer.
Okay, Shirley, we do have a couple of questions coming in. One was asking about the Cree lighting solutions might commonly find themselves in these. You talked a little bit about color tuning, and you want to mention maybe a couple of solutions that we have that might be suitable for these types of applications?
Yeah, we certainly have a wide range of linear, recessed troffers, and then we have our dynamic skylight as well, the Circadian, that you could look to work together in a space cohesively to give you lots of capabilities in terms of variability of light output. You can have the dynamic skylight as work alongside color tuning interior fixtures, either linear or recessed. So there are some really great ways that, especially for those special spaces or areas where you cannot get access to daylight. We've all seen those interior cavern-like spaces in healthcare and in large offices where it could be a very high-end corporate boardroom where you really want to give people, there are people in there for many hours a day that you want to give them a different kind of experience. So a lot of possibilities. Perfect.
Another question's come in asking about the difference between maybe an indirect source and direct lighting in this type of concept, how to kind of fit or work together or complement one another.
I think direct and indirect is a common strategy. It's an important one in terms of creating visual comfort in a space so that you reduce the potential glare of having everything be downlighting. There is certainly a cost to doing indirect lighting because we're reflecting it off of the ceiling. You're losing a certain amount in that bounce, so it comes at a sort of higher price in terms of efficiency, but it can make a huge impact in the feel of the space. So these are the kind of trade-offs I think lighting designers and consultants are dealing with every single day to try to create the best space they can architecturally in terms of the look of the lighting, and balancing that with sort of the practical side of how do we get the light on the task. But we do want more. We don't want everything to just be down lighting, because you think about trying to get light into the eye to have an impact on people. We can't have everything coming straight down overhead, or we're not going to be successful at getting the impact on human health that we need.
So there's a place for both of those in this type of concept, right? We're not excluding either one of those.
No, it's important.
Great. Well, Shirley, I think that's the last question you want to advance. We'll kind of wrap up the session.
Sure. Thanks, Dwayne.
Great. Thanks again, Shirley. And thank you to the audience for joining us again. If there's any feedback, please feel free to share those directly to me. You saw Shirley's contact information. You're absolutely free to reach out to Shirley as well. Our next session on Friday will feature controls, and Chris Evans will rejoin us as we introduce the Internet of Things. Monday's design session will be around parking garages, and then on next Wednesday, Shirley will conclude her three-part series on case studies of lighting and human health. So we'll wrap up that session. Just to remind everybody, all the sessions are posted to the Cree Lighting YouTube channel. Those will be posted within 24 hours of the event. And we also would encourage you to subscribe to stay connected and all the content that we are making available. If there's nothing else, thanks again, everybody. Enjoy the rest of your day.